This podcast is made possible by the Lighthouse Foundation for the Blind San Francisco, part of the Holman Journey 2019.
The Office of Astronomy for Development, OAD, is the joint project of the International Astronomical Union, IAU, and the South African National Research Foundation, NRF, with the support of the Department of Science and Innovation, DSI. The mission of the OAD is to help further the use of astronomy, including its practitioners, skills and infrastructures, as a tool for development by mobilizing the human and financial resources necessary in order to realize the field's scientific, technological and cultural benefits to society. This is primarily implemented through funding and coordinating projects that use astronomy as a tool to address issues related to sustainable development. Since 2013, more than 200 projects have been funded through the annual call for proposals.
Cool. All right, so we're back with our AstroHunters podcast. This is episode 6. And we're today in Capetown, South Africa. This podcast, by the way, is made possible by the Holman Prize for Blind Ambition 2019. Thanks to the guys from San Francisco Lighthouse for the Blind. So today we're at the Office of Astronomy for Development. And we have a very varied, polyvalent crew right here. And I'll let you guys introduce yourselves.
Okay, my name is Kevin Govinder, and I'm the director of the Office of Astronomy for Development.
I'm Ramasamy Venugopal, and I help to manage the projects funded by the office.
My name is Tawanda Chimboja. I'm a Development Economics Fellow here at the OAD.
I'm Vanessa McBride. I'm an astronomer here at the OAD.
I'm Nikita Madanpal, and I'm a Big Data Fellow at the OAD.
So this is a really kind of, really diverse set of skills here to actually get this operation running. So just to give you a bit of context, Capetown is really an area where astronomy seems to be taking center stage across the world, not only because of the upcoming SKA square kilometer array, which should be installed in the next coming years, and South Africa has been chosen for the grounds for that, but there's also a lot of development, including social, educational, and otherwise. But I think, Kevin, you can give us some more information about that.
Yeah, so this is a global office. It's part of the International Astronomical Union, and it's a partnership between this global body of professional astronomers, the International Astronomical Union, or IAU. It's a partnership between the IAU and the National Research Foundation of South Africa. So it's based here, but our activities are global. You see in the map behind us, we've got now 11 regional offices around the world that we coordinate from here, and a huge number of projects. The main principle of this office, or the reason that this office was established, is to try and realize the developmental benefits that can be derived from astronomy. So we set as our target the United Nations Sustainable Development Goals, and we look for any way in which astronomy, in all its aspects, whether it's from the technology to the science to the cultural links that astronomy has, we see how we can use all these aspects of astronomy to effectively make the world a better place.
This is really interesting because beyond technology and some of the scientific, research, you hit the nail with the word cultural aspect. I mean, the entire world is really, humanity has had a long relationship with the stars, and as a blind person, I truly believe that if we are able to, and that's 285 million of us, if we're able to actually look at the stars, we can also reflect it back onto our planet. And I find this kind of international collaboration to be an amazing project. So what kind of, let's start with a few things, which are happening locally. So what have you got going?
Well, maybe we can talk about the projects then.
Yeah, sure. So maybe I can start with the quote from a previous colleague of ours, Eli Grant. So she always used to say, astronomy for development is about the people and not about the stars, because I think there's some confusion when you say astronomy to people. Even if you say astronomy for development, they tend to think of us doing astronomical research rather than figuring out how to use astronomy for the development of society. So a big part of this implementation is the projects that we fund each year. So every year the IAU gives us funding and we run this call for proposals. We select about 15-20 projects each year around the world. So you can see on the map behind us the location of all the projects. So we funded about 160 projects since 2012. Close to 850,000 euros have been dispersed to these projects. So most of these projects are quite small to medium sized projects, but the main idea is how can these projects use astronomy in different ways to solve a local problem in their community, to promote development. Could be socio-economic development, something that links to the human side, as you were saying before, utilizing the science of astronomy, but also the cultural aspects, the technological innovations that have come through astronomy. In essence, using all the strengths of astronomy to figure out where exactly those skills and strengths can contribute to problems in society. And obviously we have funded a number of projects that have targeted inclusion. So these projects have, for example, developed kits, educational kits for children who are visually impaired, tactile kits of astronomical models, models of the planets and the moon, accompanied with right educational lessons that can be taught by the teachers. There's also a project that we're funding this year that's developing a tourism trail solar system walk, but specifically including people who are visually impaired. So it'll have the tactile prints as well as other sorts of making use of other sensory influences to help people walk through this solar system model, because that's something that's not been available to visually impaired people.
Yeah, the scale of the solar system, it's actually quite scaled down in many of the diagrams, and if we really put it at its true scale, it's quite astronomical, I guess, pun intended. But I guess I really like the fact that you guys are actually working on the tactile aspect of things, because I think that a multi-dimensional kind of input really solidifies memorization of things, events, incidents, things like that. And for astronomy, there's so much to actually absorb, but also to explore and discover. We, for instance, I've been working on this thing with an infrared device, so it's got a stereoscopic cameras with an infrared in the middle, which gives you an understanding of your volumetric space of 50 by 50 by 50. And we didn't actually bring it over, but we printed a 40 by 40 centimeter surface of Mars. So it's one of the craters. And you can basically, wherever you touch on it, the computer understands where you're touching, so it gives you contextual information. Yeah, so hopefully maybe we can send you that software, like one of the devices, so you can play around.
Very cool.
So a lot of all of these, I think you said 160 projects since so that's about 20 projects per year, I think, something like that. There's a lot of budgetization in things. There's a lot of there's some economic factors involved with it. How does that work?
I think most of our projects are quite creative, to be honest, and a big factor is that all the projects are run by volunteers, so they don't get compensated for their skills, so they're contributing their time and their skills to run the projects, and I think that makes it possible for us to fund all these amazing activities on very small grants.
We've been lucky to have a lot of very passionate, inspired people who are able to do a lot with a little, and that's why we have people like Tawanda on board to try and help optimize that impact that they can have.
And Tawanda, so what's your role exactly?
Okay, so here I at the Office of Astronomy for Development. Thank you very much. I work with every member of the team. So my role is basically to put the context, to fashion the development context more, because we find that scientists might have the skills, for example, programming skills, but I think many times the context itself is important as well. So while in some of the discussions there is actually a development economics course which I conduct through workshops and so forth. So it's actually just to, as I'm saying, to bring out this development context, because we find that many of the problems we're actually facing in the world, poverty, lack of transportation, some of these problems are actually coding and programming problems. I can give you an example of an application like Uber, for example, which actually matches travelers and the transport owners thereby reducing cost, and it's actually a much more efficient, but it's just basically, coding problem. So, and I also like the kind of work you guys are doing in terms of promoting accessibility, because it's not only a responsibility and obligation to ensure that there is more accessibility, to ensure that we empower everybody through STEM, through the tactiles which we were just mentioning, but it's also a very huge opportunity cost if we don't get everybody on board. So I think well done, guys, with the kind of work you are doing. Thank you very much.
Well, thank you for that. I really see, I guess it's knowledge transfer, which is really important in this context, in that you did say the company that starts with you.
Right.
I would, if I promote them, they would have to pay for this video. But
right.
I guess that knowledge transfer, because it's still just a website that solves a problem, which is a classic computer science and software engineering problem. And I guess, if I understand well, what these projects are trying to get to is to use the context of astronomy to allow different kinds of individuals from any socioeconomic level to actually be able to innovate, basically, and then create some solutions, but also having the whole point of space and astronomy and sciences as a basis from which to really kind of inspire them to get into problem solving. Am I correct with that?
Yeah, definitely, that's right. And I think what you are doing in terms of ensuring that the visually impaired can actually study astronomy, can actually study about the universe. So I think we're actually opening, further pathways for them to actually be, on board into STEM and everything.
Yeah.
But there's actually some research that shows that STEM graduates, they earn significantly higher than, than non-STEM graduates.
Yeah.
And so I think it contributes to the overall, kind of human capital, pool.
Yes.
Because economic studies actually, find that the best way to achieve development is actually by educating, by improving the quality of education of your population, including the visually impaired. So yeah, definitely.
That's right. There's a major obstacle for STEM when it comes to visually impaired students. I myself had the actual bitter experience of having to go through uni with very little accessibility. Sometimes it would take me about 8 weeks to actually get the material that I was meant to get on day one in the lecture room, and I can completely understand this frustration that a lot of visually impaired children who might actually have the mind for STEM and who might be really interested in it, and yet they get kind of veered off because of these obstacles, because they find it intimidating, or their parents or their friends, peers tell them that maybe there might be a better path for them. But I'm really truly in the belief that you follow what you're passionate about, and if you're passionate about the stars or about bioengineering or any of these kind of really new ways of understanding our planet and to help our planet, and I agree with you, science is really important, then we should provide them with the tools. So
maybe this is a good point also to chat a bit about some of the work that's been done by Dr. Wanda Diaz Merced, who worked here at the Office of Astronomy for Development for 3 years on a project called AstroSense. And her philosophy was exactly that, allowing people with the different sets of abilities to pursue their passions. So on one hand, she ran a kind of an outreach project to schools to encourage students in a love of science. And on the other hand, on a more sort of professional astronomy point of view, she had this project trying to digitize typically visual data that astronomers use. So there may be things like light curves, which is just time series of brightness of stars, or even spectroscopy data. And so this was a project that Wanda was undertaking with some collaborators at the University of Mendoza in Argentina. And the idea was really to convert these kinds of data sets into sound, because the philosophy was that many of these people with different learning modalities had ways to contribute to the scientific endeavor, if only they had ways of accessing that kind of data.
Yeah, so StarSense is... Professor Wanda, actually, she has also appeared in a TEDx. I've listened to it. I was actually quite fascinated by the transition that she actually went through, because she was sighted before, I believe, and then at some point she lost her sight. So I'm kind of in the same situation. One of the hard things is also, to try to give that visual intuition to someone who's been congenitally blind. So I have a student who I tutor who's currently doing physics and mechatronics, who's never seen in his life. And sometimes when I try to expose a visual scenario of some sort, sometimes he responds with, that's strange. So that strange is somehow associated, to the unknown. But the more tools that we can provide, just like what Wanda has actually done and her collaborators, and in a more modest way, what I'm trying to do, Astros, is that will really help many more people across the world. And I think it's not just for education, but also for people who have lost their sight and who have seen before and who do miss looking at the stars. Because I still vividly remember the beautiful ribbon in the sky when I was in the south of France. I would wake up at 3 o'clock in the morning so I could have a perfect view of the Milky Way, and I could just, mind map all of these stars and constellations and formations. And other people like myself across the world who have lost their sight either by accident or by certain diseases, they should have the right to do that as well. So yeah, this is exceptionally good work. However, there's a lot of data. So how do you guys manage all of that data?
Well, at the moment, this project is being undertaken by a student, and it's really in a conceptual phase, sort of a proof of concept phase. So if you have any ideas on how to share some of these sets of data, that would go a long way, because I think that's one of the difficulties that Wanda found, is that just as you convert one data stream into a way that people with visual impairments can access it, you find yet another data set which is in an entirely different format and needs a whole different set of conversions to be able to be accessed.
And just to say that it's not just the work that Wanda was doing, it goes beyond astronomical data as well. So much of our world today uses data, needs data, and the things you can do with good data handling skills, applies throughout. And one of the projects that we have that Nikita can tell you about is about just figuring out how to use those data skills for challenges we face in the world.
So I look at how we can use the data handling and machine learning sort of skills, or data science skills from astronomy to apply this to development-related problems. And so there's so many, I'm sure you may have heard of different applications of machine learning, but in terms of agriculture or health, or there's so many ways in which and even like language processing and stuff like that. Yes. So making things accessible in terms of translation, etc. So making these kinds of skills accessible to everyone is a necessity now with the fourth industrial revolution, and for anyone to progress, for any country to progress, we have to sort of promote these skills.
You're right, and in some ways, machine learning can be associated to automation as well. I myself actually have a specialization in machine learning and deep learning. I still kind of scratching my head to figure out an interesting way to actually put a kind of a blend of computer vision, natural language processing, as well as digital signal processing and categorization to actually provide kind of this abstracted package that you can use not just in the context of astronomy but other areas. But I particularly chose astronomy because it seems those data sets have gone through a really, really laborious amount of hours by scientists in many different fields to give us a bit more of a sense of what's happening out there. And if we can sort of, have a prototype system that kind of works across the board for this kind of data set, then that knowledge and intelligence can be transferred to other areas. So I really believe that the projects, that you guys are undertaking are really, really important for this step, especially, in countries in Africa or in Asia, in many different places across the world, to kind of have that level playing field with all of the, just across the world.
Absolutely, and the words you used, that was almost our mantra when Wanda was here. Is this really, the activities that we do? It's really about leveling the playing field. It's about recognizing that if we are to move forward, whether it is the progression of knowledge or whether it is solving problems that we face as a society, we have to recognize that we are only one part of a diverse mix of human beings who are trying to address this. And we have to tap into that diversity. And to do that, we need to make this data, make the knowledge accessible across geographic separation, make it accessible across abilities, accessible across the world. And the more people that can be a part of this endeavor, the more we can expand both human knowledge but also address challenges in the world.
Absolutely. I really kind of get back to this one thing of, because I've actually experienced it myself with a friend. If you put a bass guitarist with a drummer, or let's say a bass guitarist with a classic guitarist, you get them to play for about an hour, like a little jam session, and then you get them to swap their instruments and then continue the jam session for another hour. It's guaranteed that they will learn much more if they actually did 2 straight hours of jam session with the initial instrument. And that kind of poses, that diversity and kind of bridging, really, the perspective of different minds and different people. And, obviously, if you put 10 biologists in a spaceship and you have no engineers, there's going to be some issues, and vice versa. So, yeah, this is really kind of a vital message to actually pass through for this session. Okay, so, well, it was really cool speaking to you guys. It was very, just energetically, very different and nice, actually. We kind of switched the format a bit from one-on-one, very kind of specific and focused questions to kind of the overall project and programs that exist over here. I mean, you guys seem to be a really cool bunch to work with and stuff. I congratulate you for what you're doing here. I find it really inspiring, and I'm sure a lot of people out there are going to actually find it the same. So, yeah.
Cool. No, thank you so much.
Thank you very much.
Thanks.
Yeah, cool. All right.
After having been introduced to the scientific activities conducted by the IUA, with Kevin, Vanessa, and the rest of the crew working on machine learning solutions and a whole bunch of other interesting things which reach out into projects across the world in terms of development for the benefit of astronomy and for the education of astronomy, I was also presented to Sevrile and Tembela, who both work in the same division, which is education and outreach and media, and those two have quite some interesting things to say, including how culture in South Africa is also associated to many of the constellations that we see, one of them being the Seven Sisters in the constellation of Taurus.
All right, we're back now, and please, if you could succinctly present yourselves and your roles at the South African Astronomical Observatory.
Okay, my name is Sivuile Manloy. I work here at the South African Astronomical Observatory. I'm responsible for managing a division called Soil Collateral Benefits Program. So we involve in education and outreach, science engagement, with the public. Basically, we're trying to communicate the relevance and the power of astronomy through various projects that we're involved in, like in education. So we work a lot with teachers, learners, general awareness, astronomy awareness, and science in general. So we do science festivals, we present in science festivals, we work with the public, like with public lectures and public stargazing. And some of our staff is based in Sutherland, so where the Southern African Large Telescope is located.
Yeah.
So we're promoting astrotourism there. So I'm responsible for managing the division.
Yeah, yes. Because South Africa has quite a dark area on the planet. So really, observing the sky is actually done unimpeded by city lights and. Things like that. So that's really cool.
So my name is Tembela Mandungwa, and I also work in the Soil Collateral Benefits, and I mostly focus on public outreach, media, which is where my training is, public relations, And so mostly we do our public lectures, which are providing an interface for science to society, and we also deal with media in general as a stakeholder. And so whatever interesting discoveries we have, then we sort of write about them for media and also for the public to be aware of what it is that they are investing their money towards. What is the output and what is the future of these, of these telescopes that we constantly build and we've also constantly pay tax towards. So it's a twofold, I guess, that it's public, it's media at the same time.
So it's the, I guess the current one that you have is the SALT. Is it the SALT telescope?
Yeah, it's the Southern African Large Telescope. Yes, SALT. Yeah.
Large telescope. Is that part of a network of ground-based telescopes to that capture information in the sky? Is it mainly light curves, mainly, or is it spectrographic? Is there a way I can access that information and data to, so I could try to see what I can do with it?
The data from the SALT telescope.
Yeah.
Yes, you would have to speak with the head of SALT.
Okay.
Astronomy, and then they would tell you how you can get the data from them.
Okay, that would be a really cool thing for me to do.
Yeah. So the access that we provide to the public at SALT is through tours.
Okay.
So since these are optical telescopes, there's no sensitivity to people being closer to the telescopes, especially during the day. So we provide tours during the day, and then in the evening we also do stargazing right at the bottom. But people, the public do not have access to the telescopes at night because astronomers are working, of course.
Yeah. And so, how implicated are you currently with the Square Kilometer Array project?
Like the South African Astronomical Observatory is part of a bigger organization called the National Research Foundation, like NRF. So the SKA falls under the South African Radio Astronomy Observatory. There's another organization, right, that's responsible for the commissioning and the managing of that, right? Yeah. But we all belong to the National Research Foundation, so we are sister organizations. And the thing is, South Africa now is moving towards encouraging and developing slowly towards multi-wavelength astronomy, because these organizations have developed independent of each other. But now there's a lot of encouragement towards multi-wavelength, so collaborating and working together.
There's all of these projects going on, like in the Northern Hemisphere, for instance, with the Artemis project, so, which kind of connects different ground-based telescopes together to actually have a higher resolution view, different objects and time-based information as well. So when has the SALT since when has it been running?
2005, It was officially opened in 2005, although, there was still lots of work to be done in terms of refining the instruments and things like that, But it's been operational since 2005, yes.
Okay, so that's okay. So
that's quite a long time.
Yeah, 15 years of operation. We spoke to Vanessa and Nikita, who said that there was really SALT has an archive of all of this imagery. And I'm sure a lot of people would have a lot of interest in actually accessing that data through, like, let's say, especially coders and programmers and things like that, through an API. Have you kind of, with your outreach programs, have you created certain kind of educational things, with that information, like,
We're not with the data. We do have educational programs that are based on SALT, right? With the teachers and with the high school learners, but we have not ventured into the data aspect of it. Maybe it's something that we should consider.
Like the quizzes,
So the astronomy quiz only focuses on the content that is in the curriculum.
Yeah.
So it's not, perhaps it's something that SASTA would have to consider, because there's also, there are too many, how many facilities do we have within NRF? about
six.
Yeah, about 6. So we've got different facilities that are focusing on different things. So within the National Research Foundation, so SASTA is the one that funds the astronomy quiz competition for kids provincially and then nationally. So they might want to consider that as well. I'm sure they would be happy for that.
Yeah, that'd be really cool.
Yeah, exactly.
You know, coming from Australia, we heard there's really a lot of collaboration for the SKA between those operating the NWA, specifically Melanie Johnson-Hallett, who's actually kind of governing these and collaborating with the NREF to, get the square kilometer operational, I guess. All of this information, this data, I know that it is particularly useful for scientists, but if it's translated in a understandable way, without putting too much technical jargon, and things like that, but giving visual puzzles, with multiple answer kind of things that can sort of be generated from the data. So you don't need someone to manually create the question, but the questions can be generally, automated for each and every situation. I think it would be a really nice use of the data. You have potentially this capacity to provide a lot of people across the world a lot of content and material to do something. Plus, the archive doesn't have so much information that it hasn't been completely analyzed yet, right? In its entirety. Is this something, specifically that you could tell us a name of a star or something, of that kind that in South Africa is really kind of, has some deep-rooted cultural connection?
It's difficult to choose one.
Yeah.
Like you said, like all the people in the world have a relationship with the stars.
Yeah.
So similarly here in Southern Africa, people developed a relationship and started using stars for various purposes. Like the seasons, the stars whose constellation change in terms of the seasons. There are stars that people have identified and they use that. And like for hunting purposes, to regulate ceremonies, the stars that they use here to regulate ceremonies. Like for example, Canopus, Canopus is known across different cultures here in Southern Africa, by different names.
Right.
But people use that, like for instance in my culture, like the month of May, is called the month of Canopus. But in Xhosa they call it Ekatanzibe, Utanzibe.
Okay.
Tanzibe. So this is there's a tradition that's performed here. There's a difference in our culture between a boy and a man, right? So that month of May is used for boys that are going to go to the initiation school, to the men, right? So they kind of celebrate or mourn their last days of boyhood. So they sing and dance for the whole month before they go to the initiation school in the month of June.
Okay.
And the month of June is named according Pleiades.
Oh, the
So,
Pleiades.
yeah, the Pleiades, yeah.
Wow.
So it's called Isilime, the seven sisters. Isilime. Isilime, right? Isilime, So,
wow, that's
so there's lots of stories that are told that are based on the various stars, and there's lots of, they are used for different purposes.
Is there anything maybe with the number of the sisters? Because there's 7 sisters, right? Is there anything kind of that has any connection with that and the transition from boyhood to manhood? Why June? Is it because of the season?
Yeah, I think mainly because of the season, right?
It's mainly because of the season, and also I also stand to be corrected, but a lot of people tend to have food in abundance in March. And so going forward, that time is the time where it's free, you don't have much to do in terms of gardening or tilling the land or anything like that, and it's time where you allow your livestock to sort of roam around in your garden or your fields. And so during that time, there's no one who has a project to do because there's no plow. It's not our plowing season, and also because it's cold, and so going to initiation for boys means that they're not going to be dehydrated. So they're going to stay indoors because they have wounds that I have to tend to, and so because of that, I think it became a proper time for boys to go for initiation.
And at that time, the Pleiades are located somewhere specific in June?
Yeah. And then they start appearing in the morning. You see them in the early hours of the morning.
In the morning?
Yes, in the early hours of the morning.
Yeah. Oh, wow. And so they'll be appearing in the morning. That is really cool. That I'm gonna have to look into that. I'm gonna have to look into the name.
And also
So it's
another
Tanzibe.
Tanzibe for Canopas,
Tanzibe.
but for Pleiades, Isilimele. In fact, the other thing that you notice with that, anyway, Isilimele has got to do with planting, right? Harvesting, planting, bloom.
Not really, because the plowing season is much later.
September.
Yes, October.
But anyway, the names of, like, the thing is with the different cultures in Southern Africa, they all have this similar. There's something that needs to be studied, because even in like the different languages there, about 11 official languages. But each one has got a similar kind of name. You know, like in Sesotho and Setswana, they call them Silimela. You know, like Xhosa Isilimela, and the isiZulu Isilimela. In Venda, they call it Chirimela. So the names also sound
similar.
Yes, and I think I like that because it shows, you know, that cultural unity. That you know, like irrespective of the tribe. You know, because in South Africa we've got a bad history of, in terms of race and tribalism and things, but this also served to show that people are one, you know, the oneness of the culture, because why would we use them for similar purposes and serve similar names even if we are different groups? So I like that.
Well, guys, I still feel very young in this whole journey of astronomy, and especially the culture of astronomy. There's so much more to learn, actually. Thank you very much, actually, for your time. Let's keep in touch, and let's see how we can actually kind of, you know, move forward with this cultural aspect, because I am sure that kids and adults from other parts of the world, just like myself, would be fascinated by this information.